Hi, my dear students. Today I will be discussing about the distance between the 2 points in a Cartesian plane. Take down distance between two points. Draw the Cartesian plane. This is x-axis. This is y-axis. Now let us consider only x-axis. So this distance between 2 points can be analyzed in three ways. One is on x-axis, that is distance between 2 points on x-axis. Similarly on y-axis. And this is on the xy plane, that is the Cartesian plane. Got it? So likewise, we will explain in three aspects. So let us consider this x-axis. So here you have 1, this is 2, this is 3. What about this? This is -1, -2, -3. Now let me indicate by various points. This is A on x-axis. This is B on y-axis. This is C on x-axis. All are x-axis only. This is D. So likewise, what about y? Here y is 0. Are you able to follow? So how can you represent this? Actually, this can be represented as 1, 0. When I put 0 for y-axis means there is no point on y-axis. It lies on x only. Are you able to follow? In fact, this x-axis can be represented as x, 0. Do you understand? So when I put x, 0, any number followed by 0, that represents those points are lying only on x-axis. Got this point? Right. And similarly, when I represent this by, that is 0, y, any 0 followed by some number means that represents all points are on y-axis only. Okay? Right. So for example, how can you represent A? You can represent the point A as how? That is 1, 0. Do you understand? Similarly, what about B? B can be represented as 2, 0. Got this point? Okay. Y dash. And what about C? C can be represented as -1, 0. Okay. What about D? D can be represented as -2, 0. Do you understand? Right. Now, what is the distance between B and C? That is, let me target B and C. So I want to calculate the distance between the point B and the point C. So what you can do, you can call this one as x2, x1, and this one as x2, this point. Okay? Are you able to follow? So x1, x2, right? So the distance is nothing but the difference between these 2 points. Got it? So in that case, you can put, that is, you can adopt this formula, the distance on x-axis is equal to, you can put modulus, then x2 minus x1. What do you mean by modulus? You may get sometimes negative value, but we want to indicate this as a positive value. So that is why I put modulus here. For example, what about x2 here, this is minus 2, is it not? Put modulus minus 2 minus, and this is how much? B, I mean x1, x2 is minus 1 here, is it not? x2 is minus 1, this point. So put minus 1, and x1 is minus plus 2. Can put like this. Okay. So on this side you have x2, on this side you have minus 1. Got it? So it means what? On this side you have 2, on this side you have 1. Are you will follow? So the distance between them is this 2 and minus 1. Is it not? 2 and minus 1. So you can put, I would suggest you can take x1 minus x2 rather. x2. Okay. So x2 minus x1, x1 minus x2 means this is x1, this is x2. So 2 minus of minus 1. So it becomes what? 3. So the distance is 3. That is 3. So put the positive value. Okay. So what is that distance? This distance is BC. You can put BC. Clear? Similarly, let me write here E. So what is the distance between ED? Can you do? Try ED. The distance between ED.
3,
Yes. What is ED here?
3, minus 2.
This is 3.
Plus 3,
Comma.
minus
No, not comma. Minus 3 minus and
open
D.
open bracket minus 2.
Open bracket minus 2. So that is equal to 3 plus 2. That is 5. So already it is in modulus, so you can put 5. So ED is 5. Got it? Okay. Now you may have a doubt. Let us discuss about the significance of modulus here. Suppose, sir, you may ask me, sir, whether we had to put x1 minus x2 or x2 minus x1. In fact, both will result the same answer because we put within the modulus. So shall we try with the x2 minus x1, this AB point? Let us try. That is, we can, so note down this formula. The same aspect, that is D is equal to modulus x2 minus x1. Okay. Now what is x2 here? This is minus 1. Okay. I am talking about now BC, is it not? We want to calculate BC. Okay. So x2 in BC is minus 1. Minus, and what about B? That is 2. So in that case, the result is obtained in negative value. Okay, but we have to convert this as a positive one. That is why we have put the absolute, that is modulus. So we are able to get BC is equal to 3. Okay, so from this it's clear that whether you can subtract from final minus initial or initial minus final. Okay, but when you put within the modulus, you get the positive value. Are you able to follow this? Right, please take down. Shall I erase it? This part?
So this 3, that the D, E, F.
This I can erase this. Okay?
That only everything, sir.
And similarly, we can derive, that is the distance on y. Let us proceed. So what we have discussed, on x-axis it can be x2 minus x1 put within the modulus, or x2 minus x1. So the distance on x-axis is x2 minus x1, or you can reverse also, or x1 minus x2. Okay, please note on this. Then
Sir.
wait, let me complete. Then here on y-axis, similarly, how we can put d is equal to the modulus of y2 minus y1. Okay, or y1 minus y2. No doubt.
Sir.
And finally on xy plane, okay, on xy plane it will be slightly different. I'll explain how to do that. Now let me explain about y1 minus y2 or y2 minus y1. Let us consider this is 1, 2, 3, minus 1, minus 2, minus 3. Let me consider this point as y1, that is minus 3. Is it not? And what about this? This is y2. Let me call y2. And this is plus 3. Is it not? Now, what is the distance between y2 and y3? Let me mark this point as what? EF. Let me put F. This is G. Okay? So, FG. What is FG? FG here is equal to this. You have got y2 minus y1. Is it not? So take y2 minus y1 or y1 minus y2. So 3, absolute value 3, minus of minus, then put. Therefore 3 of 3, 3 plus 3, minus of minus plus, so 6. So FG distance is 6. Got it? You can ask me now.
சார் இப்போ நீங்கள் இப்போ எழுதுறீங்க சார், இதை வந்து அதே லைனில் போடணுமா இல்லை
வெர்டிக்கல் லைனில் போட்டு அது இதிலே போட்டுடலாம்.
இதே லைனில் எப்படி போயிருக்கீங்க சார்?
அதிலே போடலாம், தனியாகவும் போடலாம். ஓகே, please take down this. So far we have discussed about the distance between the 2 points on x-axis and y-axis. Is it clear now? Now let me work on, that is the plane, distance between 2 points on a plane. Let us now consider the third one, that is this talks about the distance between the 2 points on xy plane. What do you mean by, so previously we discussed distance between 2 points on x-axis, x2 minus x1. Distance between 2 points on y-axis, y2 minus y1. Sir, suppose if it is in between, that is lies anywhere on the plane, what we are supposed to do? Okay, there is another formula for this. I'll try to explain how to get that. Okay, right. Now let us consider, are you able to see this Cartesian plane?
Yes.
So this is x dash. So x dash means what? X-axis. That you know. Is it not? X dash. Y dash. Okay. Where I have taken x1, x2 and y1, y2. Can you get me the point of x1 here? X1 is 1. How to represent that? This is 1, 0. This point is 1, 0. What about this? 4.
4, 0.
So 4, 0. Got this point? And what about this y1? This is 0, 1.
0.
What about this? 0, 4. I hope now it is very clear. So for our simplicity, we will take x1, x2. Okay. Now consider this point. Let me take this red point. Okay. This is A. Got it? And let me take this y point. This is B. Okay. Now the distance between them. We want to calculate the distance between them. Right? And as I already mentioned, how to represent this point? x2, y2. How to represent this point? x1, y1. Clear? x1, y1. What is our objective? This is A. This red point is A. And this is B. I want to calculate the distance between A and B. Let me mark this by
x1,
1 minute.
x1, y1 plus
Yeah, right.
x2,
So let me put like this. So we are interested to find out this point. Got it? Okay?
Okay, sir.
So I hope now you are able to get a right angle. How? For example, you can draw a straight line and that is parallel to y-axis. And you can draw another straight line horizontally that is parallel to x-axis. Okay? Now let us try this. So this is the line parallel. Okay? Let me take another viewpoint here. Right? And we have another point here. Okay? So it means we are able to get a right triangle. Got this point?
Yes, sir.
This is the right triangle. So we have here A, B, and you can call it C also. So what is the distance between these two? That is D. So what about this distance? We know already, that is x2 minus x1. What about this? y2 minus y1. Okay? It's a right angle, is it not? So right angle means we can apply Pythagoras theorem. This is right angle,
Pythagoras.
90 degree.
Pythagoras.
You have to call it Pythagoras. Okay? So we can apply Pythagoras. So this is opposite side, this is adjacent side. And what about this? This is hypotenuse. So hypotenuse squared is equal to opposite square plus adjacent square. Are you able to follow? So let us have this
Plus up.
plus.
Division then, sir.
Plus. So here, what about this one? C. This is A, this is B. Let me mark this by C. Okay. So what is AB here? AB squared is equal to, write down, AB squared is equal to, this is AC squared. So AC squared plus BC squared. Okay. Now what is, that is AB is the distance here. So D squared is equal to, what about this? AC squared. AC squared is nothing but, look at this, AC squared. Okay. So AC squared, so which is nothing but y2 minus y1. Are you able to follow? So you can put y2 minus y1 the whole squared. Plus
D square, sir.
what? Yes, this is AC squared. Okay. And what about the BC? BC is nothing but x2 minus
Minus
x1.
2 minus 1, sir.
Yes. So x2 minus x1. You can take now x2 minus x1 the whole square. Got it? So d squared. What is our objective? The distance between A and B. Is it not? So we have got here d squared is equal to y2 squared minus y1 squared plus x2 minus x1 the whole square. Okay. So taking square root on both sides so that you are able to get d. Okay. Right. So taking square root on both sides. Now we are able to get the formula for this. That is d is equal to the whole square root of y2 minus y1 the whole square plus x2 minus x1 the whole square. Are you able to follow? Okay. So this is the distance formula of 2 points on a plane, Cartesian plane. So let me summarize. The distance can be calculated in three ways. One is, if the points are given on x-axis only, simply put x2 minus x1. That is the distance. And when the points lie on y-axis only, put y2 minus y1. Suppose if the distance between the 2 points that lie on xy plane, means what you are supposed to do, you have to take d is equal to the whole square root of y2 minus y1 the whole square plus x2 minus x1 the whole square. Clear? Can you explain? Come.
Explain.
Only this formula.
These formulas.
Mm.
Distance can be separated to on x-axis, on y-axis, on the xy plane. On x-axis means only from the x-axis.
Use this scale.
On x-axis.
Come this
means,
side. Come this side.
On x-axis means only from the x-axis. On y-axis means only from the y-axis. On the xy plane means both these x and y plane. D is equal to, use the only formula, D is equal to x square minus x1.
x2 minus x1.
x2 minus x1.
Modulus of x2 minus x1.
For all sums. D is equal to y2 minus y1.
For y-axis.
For y-axis. This is for x-axis, this is for d-axis.
Y-axis.
Y-axis.
And for xy plane?
xy.
Last one.
For xy plane.
Use scale. Use scale.
For xy plane.
No. Stand here and explain.
For xy plane, y square minus y1.
No, y2 minus y1.
y2 minus y1.
The whole square.
The whole square plus x2 minus x1 the whole square.
That gives you the distance between any 2 points on xy plane. Got it?
Okay.
Very good. Go.
Thank you.
So thank you, my dear students, for those who are watching. Okay.